Hi friends, is my voice is audible to you? If my voice is audible and if everything is fine, please let me know, right? Right. Okay, let me check. Let me have a look here. How many of you people are in online? If you are in online, please say hi. If my voice is audible and if the clarity of voice is also fine, please say yes. Okay, so that I will understand, right? If you are in online, please say hi. Okay, so yeah. Today's session is all about summary of IS 456 2000. In this summary of IS 456 second part, we will tackle the we will tackle about the other classes that are there in beams and slabs. Okay, this is what we are going to tackle. Okay. Before I start the session, I just want to convey a big hi to all of my brothers and sisters who are on the online. And there are so much of free content is already happening in this Unacademy learning app. If you are a serious aspirant of GATE or ESE or any other competitive exams like state PSU exams or maybe JE exams, anything, this is much useful to you, brother. So I can recommend you, if you are a serious aspirant, to install the Unacademy learning app for free content. Okay, right. And after you install this Unacademy learning app from Play Store, right, you can follow me by using this link which is given below. Use this link which is given here, and you guys are able to follow, right? This is about free content. Some people will also ask us, sir, is there any paid courses are also there in Unacademy learning app? Yes, there, best brother, there are paid courses are also there in Unacademy learning app. After you install this Unacademy learning app, select the goal or target or goal what you want to achieve. This is the goal that you want to achieve. Keep the goal or target you want to achieve as the GATE or ESE, GATE and ESE. And after that, in the main drop down menu, this is something like some main drop down menu will be there. In the main drop down menu, go to plus courses. When you had gone to plus courses in the tab of main menu, you are able to see a tab called get subscription. When you click on this get subscription, you are showing your interest to take the paid course. And in paid courses, there are two types of Shubham, right, eagerly waiting. Yes, dear Shubham, right. This month I am starting my plus course in this month I am starting my plus course. Maybe in third week of this month I am starting my plus course. I hope you are fine, right? So please, right. So here in this paid course, I can say like there are two types of courses are there. One is iconic course and second one is plus course. Both are paid courses only, but iconic is somewhat top level than plus course. Of course, I will tell you what are the advantages in taking the paid courses. Also, I will tell you. But when you are taking the paid course, when you are able to use this code VT10, the doors and windows of Unacademy will be open to you, and you are able to access. When you use this code VT10, you are able to access almost the top educators of Unacademy, right? Right. Shubham, I am teaching steel structures. I am starting steel structures. Okay. Right. So before I start this session, some people will just say, this is my first session. Na? So please introduce yourself. Right. Everybody will ask. I mean, if you are new student, right, everybody will ask. I am Venkata Tilak. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree also. My background of education is completely into structural engineering. So here also in Unacademy, I am going to teach only the structural engineering subjects, ranging from engineering mechanics, strength of materials, structure analysis, concrete structures, steel structures, and finally to construction methods and management. Okay. Coming to this university from where I had graduated, this university has produced 6 Nobel Prize winners. So producing 6 Nobel Prize winners is not a joke. First of all, you should understand. And this university ranking is far better than IITs and IIC Bangalore. This year, I don't have any partiality, brother. You can have a look directly in Google or anywhere. if you see the ranking of this university, global ranking, the global ranking of this university is always far better than IITs and IIC Bangalore. This is not told by me. This is advocated by almost all the ranking agencies across the world. Previously, other than teaching, I worked as a research engineer or research scientist in University of South Carolina for a research funded research project. This is in USA. For the same project, I worked as a team lead also. And previously, I worked as head of the Department of Civil Engineering in an engineering college called STEM. This is in Andhra Pradesh. That means I have both local experience within India and global experience outside India also. Coming to my teaching experience, totally I have 12 years of teaching experience till now in teaching GATE and ESE and in different coaching institutes all across India. Being a structural engineer, even till today also, I am working as an independent structural design consultant. I personally give structural drawings to my clients. I personally give material testing reports to my clients. These are the two things I do. Right, dear XYZ ABC, I completed my bachelor's degree from India. This is from Acharya Nagarjuna University in Andhra Pradesh. Okay. So yes, so some people will also ask us like, sir, some people will also ask us like, sir, some people will also ask us like, okay, sir, that is fine. In Unacademy Learning app, you ask us to install the Unacademy Learning app. Now, how to install that? Go to Play Store and you type this name Unacademy Learning app. When you type this name Unacademy Learning app, you can install that. You can install that whenever you are able to see a championship type of trophy. And after you install this Unacademy Learning app, you can follow me by using this link which is given here. If you press this link, you are able to see my profile and you can follow me, right? Some people will say, sir, you asked us, how we can get into the paid course, right? So how we can get into the paid course is in this main tab. I hope you are able to see. Go to select your target as GATE and ESE, and in the main code, in this main button or main tab, go to plus courses. When you are gone to plus courses, you are able to see a tab called get subscription. You use that get subscription tab and you can join the paid course. Now if everybody will say like, sir, if I touch that get subscription, how the window will be, sir? So if whenever you press the get subscription button, you are able to see a window in this way. GATE and ESE subscription, one is plus course. Do you want plus course or do you want iconic course? So coming to plus course, the cost for 12 months, before 10% discount is this much. After 10% discount, how you can get 10% discount, brother? I hope you are able to see. Do you have a referral code? Here in the referral code, you type this referral code VT10. When you are able to type this referral code VT10, definitely you are able to get 10% discount on any of the subscription, on any of the duration of subscription that you can take, right? And you can proceed to pay. And I just want to convey one more thing. The payment that you can do, either you can do by in terms of EMIs or also you can do the entire payment at a time. So there is no cost EMI is available on 6 months and above subscription plans. No cost EMI is also available. So per day you can do. So XYZ says like our advantage of plus. Here I will say the advantage of plus, brother. 1 second. Coming to iconic course. Coming to iconic course, you are able to see this iconic is somewhat superior than this plus course. And here also in an iconic course, if you want to get 10% discount, you need to use this code VT10. Whenever you are able to use this code VT10 and then definitely you are able to get 10% discount. Here before 10% discount is 50, whereas after 10% discount this has got dropped. Right, as per our brother XYZ, he is asking about advantage of plus course or iconic course, right? So what is the advantage of this plus course? What you will get if you have taken a paid subscription like plus course or iconic course. First and foremost advantage is instant doubt resolution is possible, brother. In app, directly in complete courses, you can directly talk with the educator, and after you talk with the educator, you can crack all your doubts so that you will be ready to crack any sort of competitive exam. That is the first and foremost advantage. And instant doubt resolution is the first and foremost advantage. Second advantage is you will be supported with the help of test series also. In order to crack any sort of competitive examination, test series support is required. The test series is support. The test series we are providing you in the form of quizzes, in the form of live quizzes, live mock tests, grand tests, subject wise tests. So with the help of all these tests, if you are able to write those tests, definitely you will understand at what level you people are in terms of performance when compared to the topmost students of Unacademy, and you can improve your performance. That is the second advantage, brother, when you had taken a plus course or iconic course. Coming to the third advantage, there is no need to plan yourself, brother, XYZ or any other person. There is no need to plan yourself. All the plan is provided by Unacademy. If you stick down to the plan, so definitely we are pretty much sure like you are able to crack any sort of competitive examination with very good rank. There is no doubt at all. Dear Saurav Singh, sir, please excuse me. Just after this, I will start teaching you. Please excuse me. I don't have 3 to 4 notes. Please allow me some time. Allow me just after 2 to 3 minutes. I will start teaching you. Please excuse me. Right. So right. So and fourth advantage is, so coming to the fourth advantage, you will be provided with unlimited access to all the lectures when you had taken the subscription group. Right. So whenever you are not able to come to live session, the same live session will be given in the form of recorded version to you. You can watch the recorded version for n number of times through your comfort. Okay, right. These are some of the topmost educators that we have, and the courses will be taught separately in English and separately in Hindi. There won't be any problem with respect to, I can say, language barrier. So there won't be any problem, brother. So directly you can with comfort you are able to sit in which medium you want to sit. If you are comfortable in English, you can listen to English classes. If you are comfortable in Hindi, you can listen to Hindi classes, brother. And till now in GATE and ESE, some people will ask us, till now in how many courses you people had launched in civil engineering? In civil engineering, totally we people had launched 8 courses. Out of 8 courses, few courses are in English, few courses are in Hindi. Few courses are in long-term courses, few courses are short-term courses. When you had taken the paid course, when you had taken the subscription, in our words, definitely will be provide access to all these things, right? All the courses that are launched by Unacademy in your particular stream, like in civil engineering. So coming to the financial terms, I had already mentioned that one. Every day my class is happening by 11 a.m. in this YouTube channel. This is for free of cost. GATE 2021 Rankers Batch concept through questions, and I can recommend also Kamalakar Sir Pandey's class also every day. You can watch Kamalakar Sir Pandey's class also. I just want to convey one thing. You are getting this for free of cost. Please like us, share our videos, subscribe to our videos. Please, please don't forget to press the bell icon. When you press the bell icon, when you subscribe to our videos, you will not miss even a single video from this channel, right? And we started a Telegram group for you guys also. The name of this Telegram is this one, and the name of the Telegram channel is this one. And if you want to join to this Telegram group, use this link which is given below, and if you are able to post your doubts, we will take care of your doubts, right? Right. So I hope you are able to see this one. Now we will start the question. Don't worry, brother. So everything we will do coolly, brother. Don't get tensed, don't get pressurized. So please, yes. So in a singly reinforced concrete beam section, I hope you are able to see. In a singly reinforced concrete beam section, the maximum compressive stress in concrete and tensile stress reach their permissible stresses. So if you take, so what is that answer? If you take a beam, singly reinforced beam, this is the tension reinforcement. Both the tension reinforcement and compression concrete has reached their permissible stresses, right? So permissible stresses, that means the permissible stress in concrete in flexural compression is 0.45 FCK. The permissible stress in steel is, it has got yielded, so I can say Fy by factor of safety, which is 1.5. Both these has got reached at the same time. When these are going to reach at the same time, what is the name of such section? It is nothing but a balanced section, right? Yes. J 8 says 20, it is C. Yes, it is C, brother. Yes. So yes, shall we start? Shall we move to the next question, brother? So moving to the next question. Right. I hope you are able to see this question, bro. What shall be the maximum area of reinforcement in compression and in tension to be provided in a reinforced concrete beam in RC beam respectively? What is the maximum value of reinforcement, longitudinal reinforcement in compression zone, which we people call as ASC? What is the maximum percentage of reinforcement in tension zone, AST? So what is the maximum percentage in compression zone as longitudinal reinforcement we can keep? So if you take the gross cross sectional area is how much generally? What is the answer, brother? So as per they are expecting as per IS 456. So these values will get changed with respect to other international codes. If the cross section is B and D, so the maximum percentage of ASC maximum, right? AST, area of tension steel maximum. Compression steel maximum is 4% of gross cross sectional area. 4% of gross cross sectional area is BD. So it is 0.04 times of BD. So here also in AST max it is 4% of gross cross sectional area. Gross cross sectional area is 0.04% of BD. So if the same question was asked, what is the maximum longitudinal reinforcement that can be used for a beam, and it is definitely 8% because 4% in compression zone and 4% in tension zone. So totally it is 4%. Totally the maximum longitudinal reinforcement combined together it is 8%. So directly I can pick the option is D for Detroit, right? Sir Virendra Tambi, yes, yes, good brother, right? Yes. Can you see this next question, brother? In the limit state method, I hope you know there are two types of methods. One is working stress method is there and limit state method is there. In IS 456 2000, except for water tanks, in all the cases generally we will use only limit state method. Only this working stress method is used in case of water tanks application in the design of water retained structures, right? For safety, for more safety purpose, right? So in limit state design method, the moment of resistance of a balanced section. So they are expecting limiting moment of resistance, MU limit. What is the MU limit of a balanced section using M20 grade of concrete and HYSD steel of Fe 4 and 5? If MU limit is given as K times of BD square generally, so what is the value of this K? And if you know, generally MU limit, if you had derived, this MU limit is equal to 0.138 FCK BD square. I had already derived this one, brother, in the theory classes. So in the same session, in the same channel, I had worked out limit state of flexure for 10 to 12 hours exclusively on limit state of flexure. You can go and work out the same thing, right? So in this one, what is the value? This is the answer for Fe 415 steel. If you people are expecting the answer for Fe 250, so for Fe 250, the answer is 0.148 FCK BD square. And if you people are asking for Fe 500, the answer is 0.13. We can write 0.133 FCK BD square. So these are the answers. But if you see, the question is given for Fe 415. So this is Fe 415. So I need to use what is the value of this K, brother? K, if you equate these two, definitely the K value for our given problem, it must and should be 0.138 FCK. So it is 0.138 into FCK. What is the value of that FCK? FCK is the grade of concrete, characteristic compressive strength of concrete at 28 days, which is 20 megapascal. If you work out, what will be the answer, right? Dear J, for 550, dear brother, for 550, the answer is not given, but directly you can work out, brother. So maybe you can directly work out. There is no need to tense, brother. Generally, we are using, maybe I can say 250, 500, 250, 4 on 5, 500. For 550, if you people are expecting, definitely I can say For 550, as per I can say it will be less than 0.133 FCK BD square. That's what is qualitatively I can say. If you know, if you don't, what I can say, if you don't allow me, like if you must and should do, then in such case to work out that one, you can directly work out like in this way. MU limit. You need to work out XU max by D value for FE 500, and after you work out XU max by D na, for FE 500, you need to work out generally this moment of resistance is the compression force into lever, and the compression force is 0.36 FCK B into XU max. You can write because XU is equal to XU max in case of balanced section, and into D minus 0.42 XU max. But some people the only small challenge, not small challenge before you is you need to work out XU max by D. How you can work out this XU max by D? XU max by D we can work out directly from strain triangles, right? From strain triangles, right? So from strain triangles directly you can work out. For this one, the answer is 0.138 into 20, which will be option is 2.76. For this question, the answer is 2.76. Some one of my brother J8 has asked for FE 515. Let me show that for him. Okay, let me shift to C 1 second. Let me 1 second. Let me show the answer how we can work out for my brother J. Okay, don't worry. Right. So this is how the strain diagram na in yesterday's class I teach brother. Brothers, in yesterday's class I had teach this one how you can work out from the fundamental. This is like XU max. Limiting depth of neutral axis, the strain is 0.0035 in compression concrete, and the strain at the same time in tension steel is 0.002 plus 0.87 Fy by ES. This we also derived actually. So this is already D minus XU max. This is how we can take. And this is theta, this is also theta. So obviously if I draw a line, this is theta. So from the similar triangles properties, for a given value of from similar triangles, we are able to work out. Okay, I hope you can write tan theta is 0.0035 from this triangle. Tan theta is the opposite side by adjacent side, which is XU max, is equal to, from this triangle, I hope this is the triangle how you can take. This triangle tan theta is the opposite side is how much, brother? This plus this. So I can write 0.002 plus 0.87 Fy by ES plus this is this much, right? And this value is 0.0035, so plus 0.0035 divided by depth. Depth is effective depth, na? So it is D. So from this one you are able to work out the XU max by D answer for a different grades of steel. When in this one Fi, if you put FE 500, FE 550, you are going to get XU max by D answer. Okay, right. So shall we go to the next question, brother? Let's moving to the next question. I hope. How is the deflection in RC beams is controlled? So how we can control the deflection in reinforced cement concrete beams? So as per IS 456, how we can control this deflection in reinforced cement concrete beams? Do you have any idea? I hope you know, to have adequate stiffness and to control deflection, like delta maximum due to service loads is less than delta limit. Generally there is a limiting value of L by D ratio. L by D ratio is given for different. L by D ratio for cantilever beams should not be greater than 7. L by D ratio for this is for cantilever beams. This is for simple supported beam. This value should not be greater than 20. L by D ratio for maybe continuous beam should not be greater than 26. So like this, if you are able to follow the depth, if you fix the depth such that if you fix the depth from this L by D ratio, definitely we are pretty much sure like there won't be deflection problem as per serviceability criteria can be controlled. So by controlling span by depth ratio, so directly I can say option C itself is the correct option. So they are saying by large aspect ratio. Large aspect ratio means L by D ratio. It's not that one. So by using smaller modular ratio. So modular, but it is not also the correct thing. So I can say the correct option is only C. So shall I talk about the next question, brothers? So moving to the next question. I hope my brothers are able to see this next question. What is the adaptable maximum spacing between vertical stirrups in a reinforced concrete beam of rectangular cross section having an effective depth of 300 adaptable maximum spacing? So if I take a beam, adaptable maximum spacing between vertical, this is a longitudinal reinforcement, this is a longitudinal reinforcement both in tension zone and compression zone, and generally they are saying to take care of shear, to be safe in limit state of shear, they are providing some shear reinforcement also. What is the maximum spacing between the shear reinforcement, two adjacent shear reinforcement which are provided in the form of vertical steps? So maximum S max. So if you take S max, this S max should be less than or equal to spacing that we got adopted from minimum shear reinforcement. One thing, the spacing, the maximum spacing should always be less than 300. Should always be less than. This is for by using vertical steps. Now, when it is by using vertical steps, this maximum spacing should always be less than or equal to 0.75 times of T. So this is how we can say. And they didn't talk about the minimum shear reinforcement. Nothing was given. So I can talk about 300 and this coming to this one. What is the effective depth? The effective depth is 300 millimeter. Nah? So I can say, dear J, your answer is not correct. Please check your answer. Like when it is, this should be less than or equal to 0.75 times of effective depth. The effective depth is 300. So in such case, this value should be less than or equal to 225. Will you say 225 is less or 300 millimeters less? You tell me, J. The answer must and should be 225 millimeters, not 300, just like as our brother J said. Okay. So the answer must and should be 225. There are three different clauses. So out of these three different clauses, the minimum value I need to take now. So to satisfy this maximum shear reinforcement, spacing of the shear reinforcement, right? So in such case, the option is D for dead. Yes, yes, yes. Minimum of this. Yes. So can I go to the next question, please? Right. So moving to the next question. I hope you are able to see this question. A simply supported reinforced concrete beam having clear span. Okay, they are saying this is a beam. Okay, this is a beam having a clear span. This is a simple supported beam. I hope you know clear span. Clear span is the interior distance between these supports, which is nothing but 5 meters. So it is 5000 millimeters. And support width is how much, brother? Support width is 300 millimeters, they say. And it is a simply supported beam. Right? So what is the effective span of the beam? So the effective span they are using. So I just want to say, like, some people will say, like, sir, what is the effective span? How we can work out? There is a separate clause is there for effective span also. The effective span for simple supported beam clause is different. The effective span for cantilever beam is different. The effective span for continuous beam is different. The effective span in case of beams, in case of rigid jointed portal frames is separate. There are how many clauses are there separately on this effective span? 4 different clauses for 4 different types of beams are there, right? So let me tell you. So if you know the clause, then definitely you are able to crack this answer very easily. Okay. So let me tell you the class, because our major motto is it's all about the summary of IS 456. With the help of questions we are going to tackle, right? So that we will not miss even a single class. That is our intention, right? Yes. Right. So coming to simple supported beam, this is the class that was mentioned, brother. So the class for simple supported beam is So L effective, I just want to write for simple supported beam. It is equal to, I can say this is the clear distance is LC. Clear distance LC plus D, or I can say center to center distance between the supports. The center to center distance between the supports, or center to center distance between supports. Right? Out of these two, which one is minimum? I need to consider that as a effective length of simple supported. Now coming to the first class, okay, LC it is 5000 plus effective depth. I think the what is the effective depth that was given? The effective depth of the section is given as 400 millimeter. I hope you can see. So it is 400. So it is first answer is 5400 millimeter. What's about second class? Center to center distance between supports. What is the center to center distance between supports, brother? It is 5000. This is how much? 300 by 2. This is how much? 300 by 2. So it is 5000 plus 300 by 2 plus 300 by 2. So I can say 5300. So out of this one, the minimum value, lesser value I need to consider, brother. So I can say 5300 will be the answer. So definitely. So out of these two minimum. So some people will say like just this is all about, here the question was given for something like simple support. So let us suppose like some people, especially my brother J, will ask like, sir, what is the clause for cantilever beam? What is the clause for continuous beam? What is the clause for effective length in case of beams in portal frame, right? So I just want to define that first. So maybe can I erase this one, brothers? So I just want to erase. Is that okay, brothers? Who are on the online? Virendra Tampe, Jay, or any other person who are on the online, Shubham Roy, XYZ, or any other person. Okay? Now the question is, yes, I can say effective span for cantilever. I can say the first one is, maybe I can say cantilever. If you say cantilever, you take a cantilever. 1 second, brother. 1 second. To take a cantilever of length, maybe I can say, yeah, for example, right? The effective depth of this cantilever, maybe this is the main reinforcement. The effective depth of cantilever from the extreme compression fiber is T, for example. Okay. Now in this case, how we can work out the effective length? Maybe I can say L effective. Here we can say is directly this clear distance, which is clear distance is L plus D by 2. This is how we can take L plus D by 2. This is for cantilever we can take. And some people will say like, sir, what is the answer? Yes. What is the answer for other type of beams? For other type of beams, maybe for other type of beam, I need to rub the screen. Okay, let me work out, let me show the answer for a continuous beam. Okay. Third one is continuous beam. In case of a continuous beam, there are two things are there. If support is having significant width, if there is support doesn't have significant width, if the support width is not significant, so that means this continuous beam are just like they're on rollers. Indirectly I can say, if the thickness of the wall, width of the wall is very less over which this beam is running, in such case the support width is not significant, that is not significant is less than 1 by 12th of clear span. In this case, one thing, if the support width is significant, if the support width is significant, I hope if the support width is not significant, in such case L effective length There are two clauses were mentioned in IS 4562, and it is minimum of, I can say, clear distance plus I can say W, clear span plus width of support. This is one clause. Second clause is clear span plus effective depth D. Out of these two, which one is the minimum one? Generally, we can consider that. If the support width is significant, like the width of the support or the columns over which it is running, okay, it is higher in this case. So, yeah, this may be the width is W. This is W. Width of the wall or width of the column over which width of the support, I can say indirectly. If W, width of the support is W is more than 1 by 12 times of clear span, in such case they are giving for this one effective length as it is equal to clear span, I can say. Directly it is equal to clear span. When is equal to clear span, I can say when one end is fixed in a continuous beam. When one end is fixed, I can say you can take it. Let us suppose some people say, like, if the support width is significant and if one end is not fixed, like if one end is not fixed, if one end is also just like simple supported, in such case what is the effective length, right? So effective length. So effective length, this is the answer will be, I can write here minimum of two things. One is this clear span plus half of the width by 2. Clear span plus half of the width of the support by 2. So here also clear span plus here I can say effective depth by 2. D by 2. Where I shall use this one? This clause I can use when one end is simple support. In this case, we can use this one. Okay. So based on for which type of support, which type of effective length we can use, these all these clauses were right. So moving to the next question. I hope you are able to see this question. What is the modular ratio to be used in the analysis of reinforced concrete beams using working stress method? So which method they are saying? Using working stress method. If the grade of concrete is M20. So if the grade of concrete is M20, what is the answer for modular ratio? So answer for modular ratio, generally we can say, in case of working stress method, M stands for modular ratio. It is generally it is defined as the ratio between Young's modulus of steel to Young's modulus of concrete. But it was given as an empirical formula in working stress method by using a formula called as 280 by 3 times of sigma CBC. What is this sigma CBC stands for? Sigma CBC stands for, this is in which method, man? In working stress method. In working stress method, you need to use the terminology called as permissible stress. So sigma CBC stands for permissible bending compressive stress, permissible bending compressive stress, or permissible bending compressive strength of concrete. Some people will say that how we can work out. Generally, if you see in appendix A of IS 456, there is a tabular form was also given on the sigma CBC. But if I want to say rough estimation is always it is FCK by 3 is the rough estimation of this. This is, I can say, rough estimation. That's what I can. Don't say actually rough estimation of sigma CBC. But if you want to see the actual sigma CBC was there in appendix A was there in tabular form in appendix of ES 456 2000. Appendix is just at the end. Okay, appendix A. Right now, if you say here, what is the FC? What is sigma CBC? The sigma CBC for M20 concrete general. Sigma CBC for M20 concrete. It is equal to 7 megapascal. Actually, it is 7 megapascal. If you don't know, na, generally you will write 20 by 6.66666. You can roughly take it as 7. When you take it as 7, directly the actual answer is 7. So, which is 280 by 3 times sigma CBC is 7. So, what will be the answer, brother? 280 by 3 into 7. So, what will be the answer, brother? It is 13.33. This is how we can take, and it is 13.33. So, I can say B for Boston. Is that okay, brothers who are on the online? Right? Is that okay? So, shall I move to the next question? Right? Yes, moving to the next question. I hope you are able to see the next question. Na? So, in an RCC beams, okay, as the percentage of tensile steel increases, okay, in RCC beam, as a percentage area of tension steel, PT is equal to 100 AST by BD. If this is increasing, then what will happen to the neutral axis? When the percentage of this tension steel will increase, then tension force will get increased definitely. So in such case, definitely I can say is when percentage of tension steel is increased, I can say this neutral axis will shift towards the centroid of the tension steel. So then neutral axis will keep on shift towards the centroid of tension steel. That means what we can say, that means indirectly when this neutral axis level has got going down, I can simply say like the depth of neutral axis will get increased, right? Right. Say depth of neutral axis will get increased. Yes, this option A is correct. Coming to option B, depth of neutral axis decreases. This is the wrong answer. Coming to option C, depth of neutral axis doesn't change. No, depth of neutral axis will change definitely, right? So lever arm increases. Coming to lever arm, how we can say about lever arm? Lever arm is equal to, in case of singly reinforced section, it is D minus 0.42 XU. Rather here, if XU increases, then lever arm must and should get decreased, na? So I can say lever arm decreases. So, but he is saying lever arm increases. That's a wrong option. So I can say only option A itself is the correct option, na? So can I move to the next question, brother? Moving to the next question. So I'm expecting answer from my brothers, okay, like who are on the online. Guys, can you please answer this question correctly? This is not a direct answer, but I hope you people can answer this question if you have some small bit of common sense. Okay? Maybe your concrete teacher had already teach you all this stuff. So please go to this question, and I'm expecting like if you understand this one, like most of the things, I hope some average level questions you are able to crack on your. I think then I will understand like some of the concepts, right? Sir, can we use the formula of XU for its derivation, for its determination? Formula for XU, dear brother, if you want to work out XU, always the actual, this is XU is actual depth of neutral axis. The actual depth of neutral axis we can work out from compression force is equal to tension. How we can work out compression force? 0.36 FCK B into XU. It's equal to 0.87 F by AST. They are saying like percentage of tension steel increase. When the percentage of tension steel means AST is increasing. When AST increases, what will happen to XU? XU will also get increased, right? Definitely you can do from the same thing, right? I hope I answered Abhijit Chakravarti. Okay, anyway. So moving to this question. So, sir, JS8 says, yes, total compression force at a time of failure of concrete beam section of width B without considering the partial safety factor of material. Without considering the partial safety factor of material, here this is here without considering the partial safety factor of material, this permissible stress will be FCK by the safety factor that is only coming into picture because of shape and size, which is 1.5. Again, divided by material safety factor, we are not taking, which is 0.67 times of FCK. Right? If this is the case, what is the compression force? The compression force after this one is the compression force C here directly we can take it. This depth is depth of parabolic stress block 4 by 7 times of x. The back depth of rectangular stress block, which is 3 by 7 times of x. If you work out this one, the total compression force will be 0.36 times of as per, yes, he has mentioned correct answer, 0.36 times of 1.5. So into FCK B into X. So in such case, I think you may end up with 0.54 FCKB into X. So directly the answer is option B. Yes, brother, you are correct. So can I move to the next question, brother? Right. Shall I move to the next question? Right. Is there anything? Right. So I'm moving to the next question. I hope you are able to see the next question. A floor slab of thickness T. Okay, let me take a floor slab of thickness T. Okay, is casted monolithically transfers to a rectangular continuous beam of span L and width B. Okay, the width of the beam is B and the length of the beam is L, and it is casted transverse. Nah? So it is perpendicular. So this width is B. Okay. So it is a monolithic construction. So this is a rigid joint I can take. Okay. If the distance between two adjacent points of contraflexure, it is L naught. So it is the effective length is L naught indirectly. The effective width of compression flange. When these two has got casted monolithically, definitely as this is in compression zone, the flange, this is flange and this is web. When two elements, flanges and webs, are casted monolithically, some part of the flange will act in association with the web. So definitely, what is the width of the flange that will act in association with the web? With the web that they are expecting, which we call as breadth of the flange. The effective width of the flange. How we can work out? How we can work out this effective width of the flange? Effective width of the flange. It is set for a T section, right? It is this is an intermediate beam. This is an intermediate beam. Effective width is this is B plus. I can definitely write 6 times of depth of the flange. Depth of the flange is the T here that was given. So 6 times of T plus I can say which is the effective length. Effective length of the beam. The effective length of the beam. The distance between points of two contraflexure is L naught. So I can say effective length is L naught by 6. This is for T beam I can say. For intermediate beam. TB. Some people will select that this is an intermediate TB if the end if the beam is an end beam like this. If the beam is casted in this way, the beam is casted in this way. So the type of shape of the beam that will come into picture is an L beam, inverted L beam. In case of that, what is the effective flange width? When the slab and beam were casted monolith, Bf is equal to B plus I can write here this value divided by 2. because this is an L beam now, only effective flange width is only on one side. On the left hand side there is no effective flange width na? So I can say it is 60 by 2, so it is 3T. So I can say L naught by 6 divided by 2, L naught by 12. This is how we can write for L beam. Or I can say R for end beam. End beams in case of connected end beam, I can say. So the correct one option is directly this option B, directly we can pick. Right. So moving to the next question. I hope you are able to see the next question. A reinforced concrete. Hope you are able to see. A reinforced concrete member is subjected to combined action of compressive axial force and bending moment. A reinforced concrete member, maybe they are subjected to both compressive force and they are subjected to both the compressive force and tensile force. This is how those are subjected to compressive force, axial force and bending moment also. Okay, maybe let me take is subjected to bending. Okay, now when they are acting in this way, if epsilon c is the least compressive strain, if epsilon c is the least compressive strain, the least compressive strain is epsilon c. Least compressive strain, and Fi is the yield stress of steel. Okay, Fi, everybody knows Fi, and Young's modulus of steel is yes. What is the maximum permissible compressive strain? This they are saying not bending compressive strain. They are saying maximum compressive strain, axial compressive strain, right? So what is the maximum compressive strain? What is the maximum axial compressive strain? Maximum axial compressive strain is 0.0035 minus 0.75 times of least compressive strain. You are able to see this class especially in limit state of compression. Especially this class comes under limit state of compression. So directly you can pick option C. When epsilon c is 0, in such case for that element the maximum permissible compressive strain will be 0.003. So can I move to the next question? I hope you are able to see the next question. Nah? What is this question? Can you go through that question? The span to depth ratio. The limit is specified in IS 456 for reinforced concrete beams in order to ensure. Why there is a limiting value of L by D ratio limit was specified in IS 456. For what thing they do this one? Why there is a specific limiting values for L by D ratios, right? Is there anything? Is there? I can say so that if I do this one, there will be adequate stiffness. One answer is there. One answer is there is to ensure adequate stiffness of the beam. One thing. What is the second answer? In order to keep the developing maximum deflection less than the limiting value. In order to keep the maximum developing deflection due to service loads less than limiting value of, this is limiting value of L by D ratio. This is the main trick. That means to reduce deflection below the limiting value. That is the answer. So what is the answer finally we can pick, brother? If you come down here, first option, tensile crack width is below a limit. So no, it is not so. But whenever you had limited the deflection, this is the answer. Where whenever you had limited the deflection less than the limiting value, in such case the tensile crack will be less than the limiting crack width. This is the answer to satisfy this one, not to satisfy this one. So this answer is wrong. So shear failure is avoided. To avoid shear failure, I should keep tau c is tau v is less than tau c max, and I need to ensure like whether proper shear reinforcement is provided or not. Right. So even this option B is also wrong. So coming to option C, stress in the tension reinforcement. Okay, stress in the tension reinforcement. Okay, is less than the allowable value. Stress in the tension reinforcement is less than the allowable value. No, it was not mentioned anywhere. Like if you keep a L by D ratio higher, stress in the tension reinforcement will be less than allowable value. No such thing was mentioned. It was not mentioned anywhere. Right? Even option C is also wrong. The one and only correct option is only option D. Deflection of the beam is below the limiting value of deflection. Right? So I can say D for Detroit is the correct option. So can I move to the next question? Moving to the next question. I hope you are able to see the next question, brother. As per the provisions of IS 456-2000, in the limit state method for the design of beams, okay, in the design of beams for limit state method, the limiting value of depth of neutral axis in the reinforced concrete beam of effective depth D is given by. So is XU max by D, you are going to get from strain block of and strain block as mentioned in IS 456. If you see IS 456-2000, here also I had shown that strain block. If you see this XU max by D, that strain block will be in this, right? This is point not 5, and this is epsilon st, and at epsilon st at the time of when it has got yielded is 0.002 plus 0.8785 by US. So from this strain block only we are able to work out. So this is XU max. This is XU max, I can write. This value will be definitely, this is effective depth D. So this is D minus XU max. I can say this is the depth of neutral axis when both compression concrete and tension steel will reach to yield stress at the same time. So in this case, it is actually dependent on Fi. It is actually dependent on grades of steel, right? So I cannot pick a simple answer directly. It's dependent on grades of steel. Okay. So can I move to the next question? So I hope you are able to see. This is like if the permissible stress. Whenever you usually you see the terminology called as permissible, it is completely based on working stress method. Permissible or allowable stress is the terminology. It is there in working stress method. That's like that you can understand. If the permissible stress in tension in steel in tension is 140 megapascal, they are saying like the permissible stress in steel in tension is 140 megapascal. Okay, then what is the ratio of they are saying the sigma st, which is permissible stress in reinforcing steel in tension. Reinforcing steel in tension. They mentioned that as 140 megapascal, right? I'm expecting answer from J and other persons. I mean, the depth of neutral balanced neutral axis balanced section using working stress method. Previously, this is by limit state method. This is the depth of limiting depth of neutral axis or maximum depth of neutral axis by limit state method. So by using working stress method, how you can work out that? So by using working stress method directly, the XU max formula is XU max is K into D, and coming to the K factor, it is 280 by 280 plus 3 times of sigma st into D. So 280 by 280 times of 3 times of sigma st. It's a permissible stress in tension and reinforcing state is 140 megapascal into effective depth D. If I write D, then what will be the answer? Then the answer will be definitely it is 0.4 times of D. Right? So this is the directly we can even derive this one. XU max is equal to K times of D, and the value of the K is 280 by 280 plus 3 times of sigma st. So directly the option is D for Detroit is the correct option. Okay. Can I move to the next question? This is as per working stress method. Just to use for every working stress method, if the grade of steel is changing, this sigma st will change definitely. The sigma st answer for mild steel is 230, whereas for HYS deposit is 140, like that. So it will be given in the tabular. So as the grade of the steel is changing, the sigma st permissible stress in reinforcing bar in axial tension will change. So obviously the depth of neutral axis will also get changed here, right? So moving to the next question. I hope you are able to see the next question. Nah? A continuous beam is deemed to be a continuous beam is deemed to be a deep beam when the ratio of effective span, I can say when the ratio of effective span to overall depth. When you can say a continuous beam is deemed to be a deep beam. When you can say a continuous beam is a deep beam, brother. So do we have any idea when we can say a beam as a deep beam? Yes, definitely we can say a continuous beam as a deep beam when L effective by D is not L effect is less than 2.5 when effective length of the beam by overall depth of the beam. In case of in a continuous beam, when effective length of the beam by overall depth of the beam is less than 2.5, the beam is not an ordinary beam. The continuous beam is a deep beam. And generally, we can say like another thing. Some people will say, "Sir, what are the conditions for a deep beam?" We can say a beam as a deep beam if in a beam, if depth of beam is more than 750 millimeter, that beam is not treated as an ordinary beam. That beam will be treated as a treated as a deep beam. That beam will be treated as a deep beam. If you take a deep beam, for example, in this way, you can understand physically for your physical understanding, I am going for a deep beam whose depth is more. In case of deep beams, generally the major problem for deep beams failure is generally in addition to bending moment, the problems of failure in case of deep other than bending moment is lateral torsional buckling. See, deep beams, sir. Deep beams are designed for bending moment. Please, deep beams are designed for bending moment. To take care of shear, separately these deep beams are provided at least with on the side face. This is side face and this is the side face. On the side face, says exactly because of lateral torsional buckling, shearing stresses will get developed. Please listen. Shear stresses will develop more at neutral axis and on side faces. So here exactly at this level, at this point, more and more shearing stresses are there. So on the side face, I hope you get that these are side faces. On the side faces, generally we need to provide, the code says at least the minimum side reinforcement generally I need to provide is 0.1 percentage of shear area. So on this side face reinforcement, or we people call it as skin reinforcement. These are side face reinforcement or skin reinforcement. Side face reinforcement, RF reinforcement or skin reinforcement. Why we provide that one? Generally to make that failure in terms of shearing stresses should not happen. Generally we provide, to in order to stop this lateral torsional buckling, the side face reinforcement or skin reinforcement is provided at the level of neutral axis, especially on the face or on side face. Okay, then in such case, definitely in such case, moment of inertia with respect to this x-axis is always high. Moment of inertia with respect to y-y axis will be high because the side face skin reinforcement is away from this y-y axis, right? So because of ix and iyy both are high, the moment of inertia of this section will obviously get increased. The intention behind keeping this reinforcement at side face reinforcement is to increase the moment of inertia with respect to y so that the lateral torsional buckling can be stopped. Okay. And what is the minimum? Now the question is, what is the minimum percentage of side face reinforcement or skin reinforcement? What is the minimum percentage? 0.1 percentage of web area. It is the minimum percentage of skin reinforcement we need to provide on each and every face. Okay. So the correct option for this question is 2.5. Directly I can keep 2.5. Is that okay? Can I move to the next question, brother? Right. Right. Moving to the next question. I hope you are able to see the next question. According to IS 456 specifications or recommendations or whatever that may be you call, the maximum depth of stress block for a balanced section of a beam of effective depth. See here, they had, I need to pick one option. The none of the above is not there because the limiting depth, maximum depth of stress block is dependent on grade of steel, and they didn't mention about the grade of steel. So if you see generally this maybe I can say out of 0.43, 0.55, 0.68 and 0.75 times of D, there is no such thing of 0.85, 0.4455, 0.68. Only I can say 0.443 is there, right? So directly I can pick option 0.43. And if you are expecting this for which type of thing, directly you can take this 0.43. I can say like for FE 250 it is 0.53D, for FE 4 and 5 0.48D, for FE 500 0.43 times of D. So at least this is for FE 500. Now I can pick for this option A because there is no, and somehow I need to pick one option. The one and only option I can say is option A itself is the correct option. So can I move to the next question? Yes, moving to the next question, folks. Yeah. I hope you are able to see this next question. This is a question of pattern load. This type of question will also asked in even in analysis. For a continuous reinforced concrete beam, match list 1 condition and list 2. List 1 is there and list 2 is there, and select the correct answer using the code given below the list. Okay, I can say where the maximum sagging bending moment is possible, right? Maximum sagging bending moment in a span. So if I take so many spans, this question for maximum sagging bending moment I already teach you in your previous class, right? So can you tell us where if 1, 2, 3, 4, if there are 5 spans? So I want generally the maximum sagging bending moment is possible at the interior span. At the interior span at mid level. If I want to get maximum sagging bending moment at interior span at mid level, I need to generally load this interior span at the mid with this complete. So if I want to draw the sketch, this is how. If I say this is how the deformation sketch is for, right? So if I want to get more bending moment here at this point, so in this case, if in addition to this interior span, if I am able to load the alternative spans, this one, then definitely I am able to get maximum sagging bending. So interior span or mid level span and is loaded plus alternate spans are to be loaded, right? So I can say, okay, right? Say the same span as well as I can say same span as well as span alternative span should be loaded. Okay, this should be loaded and this should be loaded. So for maximum sagging bending moment, I hope you can say the span adjoining the span as well as alternative span. No. The same span as well as alternative span should be loaded. This is the correct. I mean, for option A, second one is correct. Coming to maximum hardening bending. So how to get the maximum hardening bending moment at a support? So maybe I can take the same stuff 1, 2, 3, 4, 1, 2, 3. If I had taken this is the interior span, maybe here at the interior support, I will get maximum hardening bending moment. If I want to get the maximum hardening bending moment here, how you will load this maximum hardening bending moment? To get the maximum hardening bending moment here, maximum reaction should be there. So in such case, to get the maximum reaction, generally I will keep the loading in this way, and I'll start keeping the loading. Okay, 1 second. Right, that means this span has got down, this span has got down. When the span has got down, then only this will go down, this here and this here will go down. So because of which here at this point this will come up. So directly I can say I should even load here also in this span and in this span. How we can say about these ones, that the adjacent spans on both the sides, I can say that this is what means of this one. The adjacent spans on both the sides of the support as well as spans alternative to this, right? These are the two adjacent spans. So adjacent spans on both sides of support as well as spans alternate to these. So that you can say like for B, the correct option is only 3, right? B is 3. So coming to option C, they are expecting maximum Hagen bending moment only. This is at support. This is in span. If you want to get maximum Hagen bending moment in span, right? So what should be done? The maximum Hagen bending moment in span. The spans adjoining I can say like the span adjoining the span as well as alternative span. So I can say for C, I can say this is C. First option is the correct one, right? So this is how we can do. Now you can see option A, option B, and option C were well matched, and I can say option A itself is the correct option. Is that okay? This is a question on pattern loading. Based on this pattern loading only, you will understand how to keep the live load so that I will get maximum. How on structure I am able to get maximum sagging bending moment, maximum hogging bending moment at supports and in span support. Okay. So can I move to the next question? Right. So can I move to the next question, brothers? Jay, Saurabh Singh. Okay. Any other person? Okay, I'm moving to the next question. I hope you are able to see the next question. In a doubly reinforced rectangular beam, okay, let me take a doubly reinforced rectangle. Okay, take a rectangle. The allowable stress in compression steel. This is tension steel. Okay, this is compression steel. We call compression steel as ASC. We call tension steel as AST. Okay. The allowable stress in compression steel. Generally, what is the stress that is developed in compression steel? Generally, tension steel is heated. Tension steel is heated. Whereas in compression steel, stress developed is less than permissible stress. So in compression steel, the stress developed is less than permissible stress. So how we can say it is less than permissible? So how we can say about this one? So the stress is less than permissible stress, right? So you can say it is not equal to permissible stress, not more than permissible stress. It is less than the permissible stresses in tension in steel. So when compared to the stresses in tension, permissible stress in tension, the stresses developed in compression steel is less than the permissible stress in tension zone. Definitely, I can say option C itself is the correct option, right? So moving to the next question. I hope you are able to see this question. Next question. Can you see the side face reinforcement if required in a T beam? If what is the side face reinforcement? People call it as skin reinforcement. This I had already given as a class by the time of when you need to provide the skin reinforcement. Skin reinforcement I need to provide on beams, especially on beams which are deep in nature. For deep beams, I need to provide the skin reinforcement. What is the percentage of skin reinforcement I can is required in a D beam? You can take D beam or any side. I can say D beam, some D beam, or in D beam also. In D beam, if you take in T beam, it has got flange and has got web. Whenever there are flange and web elements are there in beam, whenever there is some web is there, especially in such case for web, certain side face or skin reinforcement should be provided. What is that value of that side face or skin reinforcement? Side face reinforcement is 0.1 percentage of shear area. Shear area is nothing but 0.1 percentage of shear area. So it is 0.1 by 100 times of area of the web, because shear area is nothing but area of the web. Because from the fundamentals of strength of materials, moment is taken care by flanges, whereas shear is taken care by webs, right? So that's the reason why I can write shear area as web area. So I can say option A itself is the correct option, right? So moving to the next question. I hope you are able to the next question. D beams are designed for. What is D beams are designed for? D beams are designed for bending moment only, right? Isn't it or not? So D beams are designed for bending moment only. So can I move to the next question, bros? So I hope we are in this next question. The effective depth of a singly reinforced rectangular beam is the effective depth of singly reinforced rectangular beam. We draw a singly reinforced rectangle. Maybe some steel. Let me provide. The effective depth is D. Na? We show with another color. If this is D, what is value of this D is 30 centimeter effective depth. Section is over reinforced. Okay, the section is over reinforced. And the neutral axis 12 centimeter below the top. From the top, the neutral axis 12 centimeter. 12 centimeter. Okay. If the maximum stress attained by concrete, when it is over reinforced, maximum stresses will be developed in concrete, whereas steel is under stress. Steel is under stressed, whereas concrete will reach its maximum value of permissible stress. So here concrete will fail. Okay, right. And the modular ratio, they are giving modular ratio as M is 80. Whenever you see this, the maximum stress attained by concrete is okay. And whenever you are able to see this modular ratio, 80, then you should understand like this is the question that was asked by using this working stress method. Okay, then the stress developed in steel. What is they had given the actual depth of knot, which we will call it as XU. Okay, so if this is XU, if I want to draw the strain block, right? If I want to draw the stress block, how the stress block is there? What is the assumption of stress block in case of a in case of working stress method? I hope you know. So can you draw the stress block, brother? I hope you are able to draw this stress block in this way. Stress block is just linear variation in case of working stress method. How you can say it as working stress method? Because they are saying like modular ratio and all this stuff, right? So directly you can understand it's completely based on working stress method. Whenever in case of working stress method, the variation of stress block is just like that of a straight line. How the variation of stress block is there. And here which one is failing? I can say the failure is happening in concrete, which is sigma CBC. Permissible stress in concrete and bending compression. It is 50 kg per centimeter square. What is the strain? What is the strain? What they are saying? What is the stress developed in steel? So they are expecting sigma XT. If this is sigma CBC, if I convert this into, if this is a stress block, I need to convert this into equivalent concrete stress block, right? What is equivalent stress equivalent what is the stress in equivalent area of concrete for this steel? It is sigma I can say FST. FST is the stress developed in steel divided by modular ratio. Then this is the stress developed in the equivalent area of concrete. If this is the case, this is already XU, right? So I hope from this one you can easily work out this thing. When this is 12, this is 12 centimeter, 12 minus 30 minus, this is 30 centimeter, this is 12. So this option, this is 18. Right? So from this one, they are expecting FST. What is that FST? This stress developed in tension steel is that one. The stress developed in tension steel is always less than permissible stress of tension steel. See here FST is less than, I can say FST is the, how we can write, developing stress in steel is less than permissible stress, permissible tensile stress of steel, right? Generally in this case, this is FST by M. What is that M value, brother? The M value is 80. If you take from similar triangle property, this is theta, this is obviously theta. So directly I can write tan theta is equal to opposite side is 50 by adjacent side is XU. XU is equal to 12 centimeter. Divided by 12 is equal to opposite side is this FST by 18 divided by this is 18. So in such case, what is the answer of FST, brother? 50 by 12 into 18 square. Right. If you work out this one, it is 1350, and this value of 50, if you see, this is in 50 kg per centimeter square. Na? So obviously, I will get the stress that is developed in tension steel will also be in kg per centimeter square. So directly we worked out this stress developed in steel directly from this stress block, which is option C. Hi Hitesh Garg, yes, you are correct. So can I go for next question, brother? So moving to the next question. So can you see this question? Which one of the following statements about the percentage of tension steel required to produce a balanced reinforced concrete section is correct? So for balanced reinforced concrete section, which of the following options are correct? That's what is the question. Okay. So for balanced section, both steel and concrete reach their design stresses, right? That means steel has got yielded and concrete has also got yielded. Both steel and concrete have yielded. You can write in this, right? In this case, directly the required percentage of steel. Okay, which one of the following statement about the percentage of tensile steel required to produce a balanced reinforced concrete section? Okay, what is about the percentage of steel? Okay, coming to the percentage of steel, I can say percentage of tension steel. So what is the percentage of tension steel? Coming to percentage of tension steel, if C is equal to T, they are talking about yield strength. When I say compression force is equal to tension force. Compression force is 0.36 FCK B into, I can write XU max, or maybe because they are saying for a balanced reinforced concrete section, I can write XU max is equal to 0.87 F5 AST. So if I want to write AST, this is for balanced section. When AST of balanced section, how you can write this is 0.36 FCK B into XU max by 0.87 F. When F5 increases, then AST of balanced A of steel required for balanced section decreases. Percentage of AST decreases, right? So reduces as yield strength of the steel increases. Yes, first option is correct right now. Coming to the percentage of steel remains unchanged irrespective of yield strength. No, it is not wrong. It is dependent. It is inversely proportional. From this one, we are able to understand, na? Right? So option B is wrong, right? So coming to option C, it is the same for a given quality of steel, irrespective of whether working stress method is followed or limit state. Here for limit state method, this area of balanced steel is different, whereas for working stress method the area of balanced steel has got different, because compression force value is different and tension force values are different. So I cannot say option C is also correct. So coming to option D, is only a function of this percentage of tension steel is only a function of modulus of inertia of steel. No, it's a function of Fy, function of FCK, function of B and XU max and all this stuff, right? So D option is also wrong. Only the correct option that is matching is only option A. Is that okay? Right. So can I move to the next question? Yes, moving to the next question. The minimum clear cover in the main steel bars, in slab, in beam, in footing, in column and footing, in slab. For slab, when the diameter is less than or equal to 12 millimeter, cover, when clear cover is 15 millimeter. When phi is more than 12 millimeter in slab, the cover is 20 millimeter. In case of beam, for beam, the minimum clear cover is 25 millimeter, and for column, the minimum clear cover is 40 millimeter, and in case of footing, the minimum clear cover is 50 millimeter. This is in case of mild exposure. In case of footing, in case of severe exposure, it is 75 millimeter. Right? So if you can say what will be the correct option, brother? So the first option, the minimum value is 50, right? Here it is 20. Okay, you can say option A itself is wrong. Now coming to this option C, here 25, this is 30. This is also wrong. And coming to option D, it is 20. Okay, maybe you may say take this one. And for beam, it is 35. Okay, for column, it is 40. Now the minimum clear cover for beam is 45 millimeter only, but here has given here 35 millimeter. So directly I can say even this is also wrong. So directly I can pick only option B for Boston is the correct option. 43 B for Boston is the correct option. Right? So footing, the minimum cover is 50 millimeter in case of mild exposure, whereas when the exposure condition like severe exposure, the minimum clear cover is 75 millimeter in case of salty soil. Right? Yes. 43 B for Boston is the correct option. Can I move to the next question? I hope you are able to see this one. Beam sections, okay, beam sections designed in accordance with limit state method are compared to the sections designed in accordance with working stress method. So limit state method are more economical sections than working stress method. Generally, this is the conclusion. Right. Generally, when you take a limit state method, if you take limit state method, for limit state method, depth required is equal to square root of m by mu limit. Generally, if you write mu limit is equal to maybe q times of 0.13 FCK, we can write BD square. So I can write q times of B, we can write where q is equal to maybe I can say 0.138 FCK or maybe 0.133 FCK or maybe 0.143 FCK. So it depends on the grade of plant. This is as per limit state method. If you take working stress method, here also depth required we can take as square root of m by QBD square. Here you can write Q and P. Generally, the value of this Q is here, the value of Q is high. Q value is increased in limit state method, whereas Q value is decreased in working stress method. So obviously you can say like depth required is less in working limit state method than depth required in working stress method. So depth of the section required is less for limit state method. So smaller depth I can say, there is no doubt. And coming to reinforcement, whereas coming to reinforcement I can say, so coming to depth required, this is the conclusion. Coming to reinforcement, generally we provide coming to reinforcement in LSM limit state method, more reinforcement and less depth. So I can say like smaller depth is there for limit state method and more reinforcement is there for limit state method than working stress method if other parameters are all are same, right? So I can say like option, if I move to this option A, larger depth and smaller amount of, it is completely vice versa. Larger depth and smaller amount of reinforcement is there for working stress method, right? So coming to this option B, I can say smaller depth and same reinforcement. No, smaller depth is fine, but same reinforcement is not the same. Is not the correct one. Smaller depth and more reinforcement. Yes, it seems like correct. Same depth as that of deep beam. No, it is not same depth. How you can mention that is deep beam and all this stuff? So the correct option is only C. Right. So like that we can mention. So going to the next question, brother. So moving to the next question. If the depth of actual neutral axis in a beam is more than critical depth of neutral axis, so they are saying XU is greater than XU max. When XU is greater than XU max, it is over reinforced section. It is over reinforced section. So directly here it is over reinforced section. Directly I can pick C like over reinforced section. Directly I can. This is from the fundamental, right? I hope you are able to see this question. A continuous slab is there, okay? A continuous slab is there of 3 meter by 3.5 meter size. The minimum overall depth of slab to satisfy vertical deflection. Continuous slab of 3 meter to a continuous, you can write two-way slab. For a continuous two-way slab of 3 meter by 3.5. One depth, one is 3, another one is 3. Is 3.5. This is Ly, this is Lx. The minimum overall depth to satisfy vertical deflection limits. What is this Lx by d value? Lx by d value for a two-way slab, and they are using the type of reinforcement. Generally, the type of reinforcement also must and should be given for continuous slab. For a two-way slab using mild steel. The answer, this value should always be less than or equal to 40 for mild steel. Lx by d for two-way slab. Generally we won't use mild steel. We generally use HYST steel. Right? For HYST steel, this value should be less than or equal to 0.8 times of 40. Right, so this value is 32. Generally, as here the nature of that the reinforcement was not given, I am taking directly this HYSD, but because for main rods generally we will use mild steel. Only mild steel is used generally for shear reinforcement. So I can use, this is the practical thing. This is not practically used. Not practically used for two-way mild steel. This is HYSD steel. Mild steel is not used for longitudinal reinforcement. So I can use this limits as 32. When I use this limit as 32, in such case, you tell me Lx is small depth. Na? So I can say like d Lx by d should be less than or equal to 32. So d should be greater than or equal to Lx is 3000 millimeter. What is this effective depth d? Effective depth d should be greater than 93.75. They say 93.75 millimeter. What is the overall depth d? Overall depth is equal to 93.75 plus effective cover, I can say. What is that effective cover? Effective cover, clear cover itself is 15 millimeter generally. And clear cover is 15 millimeter, effective cover will be almost 20 millimeter. And I say this one as 20 millimeter. In such case, this overall depth, capital D, I can say, this capital D overall depth will be depth will is equal to 10.8 or 10.9, or I can say, instead of that one, I can say 109 or 110 millimeter. When it is 110 millimeter in terms of centimeter, overall depth is 11 centimeter. When it is 11 centimeter, they are expecting minimum overall depth. Minimum overall depth is 11 centimeters. So this option C is wrong. Option B is wrong. 10 centimeters is also not sufficient. If it is effective depth, then 10 centimeters is sufficient. If it is overall depth, I require at least 11 centimeters. So obviously 12 centimeters may be the correct option at I think. So option directly is 12 centimeters approximately. Yes. Right. Like that we can mention the answer. Right. Can I move to the next question? Because actually here this type of question will not be given, because especially in your competitive examinations they should mention the type of steel also. If they don't mention the type of steel, then everybody may think like this is 40 is the limit they may take. That may give you a wrong impression and you may pick a wrong option also. Okay, so moving to the next question. So coming to this question, the minimum reinforcement using mild steel in slab. What is the minimum reinforcement using mild steel in slab? So minimum reinforcement percent is 0.15 percentage of gross AG stands for gross cross section area. Whereas this is by using for mild steel. Some people will say that if it is used by HYSD, because nowadays we are not using mild steel as main reinforcement. If I use HYSD, just like practical, for HYSD steel, in such case it is 0.12 percentage of gross cross section, which is 0.12 by 100 times the cross section. So as per they are expecting for mild steel, so I need to pick 0.15 percentage, which is option C. If it is for FE 4 and 5, it is why I should provide this minimum reinforcement. Generally, some minimum reinforcement must should be provided. Even compression zone also. Why? Even compression zone also certain minimum reinforcement is required. Is there any idea? Generally, to take care of stresses because of shrinkage, creep, okay, temperature stresses. These are not the stresses that are coming into primary action. These are the stresses that are coming into picture because of secondary action, right? So to take care of that secondary stresses, at least some minimum steel is required. That minimum steel is nothing but this secondary reinforcement, this secondary steel that we can say, and secondary reinforcement we can say that is the minimum reinforcement that I need to keep to take care of, let's say, secondary. Okay, so I hope you are able to see in the reinforced concrete slab. I hope you know a reinforced concrete slab. Spacing between the main reinforcement should not exceed Reinforced concrete slab. I hope if you take a concrete slab, spacing between the main reinforcement. What is the spacing between the main reinforcement should not exceed, that is S max. The S max, what is the spacing for S max in case of slabs? In case of slabs, this should be less than 300 millimeter, and this should be less than 3 times of effective depth of slab for main reinforcement. So 300, that option is not given. Now, out of these two, which one is less? I need to pick, right? In such case, I need to pick 3 times of its effective depth, which is option A itself is the perfect option, that is matching with the classes. This is main reinforcement. So can I move to the next question? Moving to the next question. I hope you are able. The reinforced concrete beam carved in plan. Reinforced. Can you tell me an example for reinforced concrete beam carved in plan? I hope you know a beam carved in plan is in case of beam beam for a water tank. Beam for a if you take this is in plan. In plan, I take these are all four columns. This is in plan. How the ring beam, I hope you can see, ring beam for a circular water tank. This is how the beam can be. Circular water tank. This is a circular. If you take the center line of this beam, this is how the center line of the beam. This is how the center line of the beam is. Now this beam is actually designed for what? This beam is designed for what? This beam is here because the loading is here. This beam, whenever there is a beam, it is subjected to bending moment and shear force. But where this is the center line of the beam. The center line of the axis of the beam is not coinciding. This is the loading. The loading between the loading and the center line of the beam, there is eccentricity. So because of which this beam is subjected to twisting moment, which we people call as torsional moment. So bending moment, shear force, and torsional moment. These are the three major internal forces that will be developed. So I can say directly say option D itself is the correct option. Generally for normal beams, when the plane of loading is coinciding with the centroidal plane of the beam, in such case there won't be any twisting moment. But when the plane of loading is not coinciding with the centroidal plane of the element, in such case torsional moment will come into picture. So can you see this one? Spacing of shear strips in a reinforced concrete beam. I hope you know, in a reinforced concrete beam, take this is the main reinforcement. Maybe this you are main reinforcements. Spacing of shear stirrups. You are spacing of shear stirrups in a rectangular reinforced concrete. What on what basis this spacing is dependent? This spacing generally spacing of shear reinforcement should be kept closer where the shear force is higher. When the shear force is lesser or zero, spacing can be increased, right? Spacing should be kept closer where shear force is higher. whereas spacing of shear reinforcement is increased. Spacing of shear reinforcement is increased. The points shear force is C or 0. Generally, if you take framed structures or any other normal beams, generally, if you take normal beams or framed structures, shear force is minimum at the center line. If I take with respect to uniform system, this is how the shear force is. Shear force is less or zeros at the midspan, right? Even in case of framed structures or anything, the shear force is less towards the center of the span, right? So I can say as the shear force is less towards the center of the span, the stirrups spacing can be increased towards the center of the span. So I can say it is increased towards the center of the span, right? So directly I can say 51D for Detroit is the correct option. Now moving to the next question. I hope you are able to see this question. Shear strength in a reinforced cement concrete beam is a function of shear strength in case of reinforced cement concrete beam, which is called as tau c. Shear strength of RCC beam. This tau c, on what basis this tau c is dependent? Tau c is dependent on FCK and tau c is dependent on percentage of tensile uh, tensile steel area. PT is equal to 100 AST by BD. So if you see from table number 19, if you go and refer from table 19 of IS 456, the shear strength of RCC beam is a function of FCK and it is a function of percentage of tension. So I can say option D itself is the correct option for shear strength of reinforced concrete beam. Let us suppose in the same question, what is the permissible shear strength of concrete is a function of what? Permissible or design maximum shear strength of concrete element, which is called, people call as tau c max. If you see this tau c max for even in limit state method, it is equal to 0.25 times of root FCK. In working stress method, it is a function of 0.16 times of root FCK. So it's a function of FCK only. That means the permissible or design shear strength of concrete. If you would say permissible shear strength of concrete alone, that permissible shear strength of concrete alone is a function of FCK only. There is a lot of difference between shear strength of RCCB and shear strength of concrete alone. Tau C max is a function of FCK. Right. So if this is the question, you need to pick answer as only FCK. If this is the question, you need to pick the answer as. So that is how it is one different from each other, right? So moving to the next question, brother. I hope you are able to see. The slab is designed as one-way slab with the ratio of long span to short span. Ly by Lx is taken as one-way slab. When it is taken as one-way slab, it is greater than 2. So when it is greater than 2, then we can design that slab as a one-way slab, right? So I can say it is greater than directly 2. I hope you are able to see this next question here. For a slab supported on its 4 edges, if you take slab supported on its 4 edges, okay, you take a slab. which is supported on its four edges with corners held down. The corners held down, say corners held down, okay. Right. The Marcus correction factor to the moments obtained by Grashoff-Rankine theory. What is Grashoff-Rankine theory? Using this theory, we are able to find out the bending moments, bending moment coefficients. Mx is equal to alpha x into w lx square. My is equal to alpha y into w y square. It's alpha x coefficient and alpha y coefficient for tabulated for two-way slabs by using this Grashoff-Rankine theory. For this Grashoff-Rankine theory, sometimes some correction we should do for bending moments. And what is the name of that correction and how we can do that correction? The correction was actually given by Marcus correction factor to the moments, that is obtained by Grashoff theory, and that correction factor is 1 minus 5 by 6 times of r square by 1 plus r to the power 4. This is the correction factor. Some people will also ask us, so if you say multiplied by correction factor, I can say multiplied by correction factor. This correction factor generally we need to do when this is the correction factor as given by Marcus. And what is the value? What is R stands for? R stands for here, it is the ratio between long span to short span. Long span to, yeah, Lx square only. W Lx square. Yeah. Long span. Sorry. Yes, Lx is right. Yes. Yeah, by Lx is right. Because bending moment is a function of short span here only. Because along short span it is more rigid now. So more and more bending moment is developed in x direction only. So coming to R is a function of, R is the ratio between long span by short span. So if you take this R is long span by short span, always this factor is always less than 1. Man. This factor is always less than 1. So directly we can pick option A for Amsterdam is the correct option. So moving to the next problem, brother. Right? I hope you are able to see the next problem. For a simply supported beam of span 15 meter, the minimum effective depth to satisfy the vertical deflection limits. So what is the minimum? To satisfy vertical deflection limits? What is the minimum effective depth we need to keep for? So here I can say L by D ratio for simply supported beam actually should not be greater than 20 when span is less than or equal to 10 meter. Some people say like, sir, when span is more than 10 meter, what will be the correction? When span is more than 10 meter, then this L by D ratio for simple support beam 20 into, we can write 10 by span. This is the thing as per IS 456. So our span is 15 meter. Na? Here divided by 15. In such case, L by D for simply supported, revised L by D for simply supported should not be greater than 13.33. So the span is already 15 meter. Na? So depth should not be less than 15,000 divided by 13.33. So in such case, the minimum depth should not be less than 1125.28 millimeter. So depth should be more than 1125.28 millimeter. So the minimum depth is not 600, not 750, not 500. It is more than 1.125. So to be frank, I should write as it is more than 1.125 meter. So I can we go for option D for tetrite is the correct option, right? Yes. For today, I think the almost 2 hours has already gone. So please excuse me. We should stop this session by this time. We will work out the remaining questions in your next coming class. I mean tomorrow. Okay. Before I end up this session, I just want to say, like, if you are a serious aspirant of GATE or ESE or any other competitive examination, I can definitely recommend you guys with this paid course subscription, either Plus course or Iconic course. Coming to Plus Unacademy Plus subscription for 12 months, the cost for after 10% discount is 27,225 for 12 month subscription. I can recommend this 12-month subscription course to the students who are in final year are passed out students. Whereas if you are an aspirant of GATE or ESC and if you are in second year or third year, I can recommend you guys with this 24 months course. The 24 months course after 10% discount is 39,600. The cost is 39,600. So for any of the course from 1 month to 24 months duration of subscription, to get 10% better, you are bound to use this code VT10. When you use this code VT10, the doors and windows of Unacademy will be open to you. There is no need to go to Delhi, Bombay, Kolkata. Topmost faculty of India are directly right now available at your doorstep through Unacademy. So this is the using single code. The doors and windows of Unacademy will be open. And every day my class is happening in this YouTube channel. Every day my class is happening by 11 a.m. So don't forget to come down to my class. Right. I can also recommend Kamalakar Sir Pandey's class also. So his class is happening every day by 9 a.m. I can even recommend Kamalakar Sir Pandey's class also. You can go through his class also. And fine, last but not least, finally, I can tell you, you are getting all this for free of course. Please raise a thumbs up. Okay, please raise a thumbs up and please share this video to your friends also. And this is for free content channel. Your friends will also get motivated and your friends will also get help. It is more helpful to your friends also because there is no need to pay anything for this YouTube channel, right? So please convey the same thing to your friends so that other friends of you will also be benefited, right? So please subscribe to this channel, brother. Don't forget to subscribe to this channel. Please say your friends to subscribe to this channel, and don't forget to press the bell icon also. When you press the bell icon, the future coming videos in this channel will be notified to you. So that's what it is. The major thing that I can say. Don't forget to press the bell icon, and please raise a thumbs up. And even YouTube comments are also welcome. And I can convey you, like, we already started a Telegram group, and the name of the Telegram group are Let's Crack GATE and ESE Civil channel. That is the name of that Telegram group, right? And the other Telegram group is also there from Unacademy, Unacademy _ Venkata Tilak. If you come down to this channel, you just use this link which is given below. If you are able to use this link which is given below, definitely we are pretty much sure, like, definitely whatever may be the doubt that you post in this Unacademy channel, we will resolve your doubt. Definitely, there is no doubt at all. Please come down to this channel so that you can post your doubts directly in this Telegram group. Okay, thank you very much. End of the session.